expression, you're first going to determine the GCF of the coefficients and variables, then divide each term by the greatest common factor, then write the greatest common factor in front of the parentheses and fill in the remaining numbers and variables inside the parentheses. So first we have to start by determining the greatest common factor. So if I determine my greatest common factor of 7, or my factors of 7 to start, I can list them so I have 1 and 7. Then I will list my factors of 5, which I have are just 1 and 5. Now the greatest common factor of the numbers is 1. So the greatest common factor is the numbers part is 1. Then I'm going to do the same thing for the variables. So in terms of my variables, for b to the third power, that means I really have 3 b's. And for b to the second power, this means that I really have 2 b's. Now if I look for what's in common, both of these have at least 2 b's, so the GCF of the variables is b squared. So now if I put my greatest common factor together, including both of these, I have the greatest common factor of the numbers, which is 1, times the greatest common factor of the variables, which is b squared. So I can say that my greatest common factor is just b squared. Now what we have to do from here is we're going to take this value and divide it into the original expression. So what that means is that I'm going to take this b squared, I'm going to bring it up over here and divide both of these by b squared, and then bring the b squared in front. Now the inside of the parentheses is what's left over. Now the numbers don't change because this is really a 1. So 7 divided by 1 is just 7. And in the first expression, I start with 3 b's and I take away 2, so I'm left with just b. Or the quotient rule, I subtract the exponents. For the second term, 5 divided by 1 is still just 5. And then when I divide by this b squared, these b squareds end up canceling out. So my expression becomes b squared times 7b plus 5. You need to make sure that you include this b squared in front, because if that's not in front, then your answer is not going to be correct because it doesn't give you the equivalent expression. In the next example, I again start by listing my factors to determine the greatest common factor. So if I list my factors of 16, I have 1 and 16, 2 and 8, and 4 and 4. Then if I list my factors of 24, I have 1 and 24, 2 and 12, 3 and 8, and 4 and 6. Now the common factors here is they both have a 1, a 2, a 4, and an 8. Now the greatest of these common factors is this 8. So the GCF of the numbers is 8. Then I'm going to look at the variables. The first term has x squared, so I can rewrite that as x times x. The second term is just x, which I know is really just 1x. So if I look for what's in common here, I can see that both of these have just 1x, so the greatest common factor of the variables is just x. So this means that my total greatest common factor is again the greatest common factor of the numbers of 8 times the greatest common factor of the variables of x. Now what I have to do is I take this greatest common factor of 8x and divide my original expression by it. So I'm going to divide both of these by 8x to factor it out and leave it in front of the parentheses. Now the inside I'm going to divide, so I have 16 divided by 8 gives me 2, and if I have x squared divided by x, I take away 1x, so I'm left with just x, plus 24 divided by 8 is 3, and these x's cancel. So my expression is just this 8x times 2x plus 3. In the next example, I start by listing the factors of my coefficients. So my factors of 2, I have 1 and 2. And then my factors of 4 are 1 and 4 and 2 and 2. Now the common factors are they both have a 1 and they both have a 2. So the greatest of these common factors is 2. Then I'm going to do the same thing for the variables. So the first variable is x to the third. So I have x times x times x. And the next variable is just x. So that means there's 1x. Now if I'm looking at the common factors, both of these have at least 1x. So the greatest common factor is x. Now my overall greatest common factor is combining the greatest common factor of the numbers, which is 2, and the greatest common factor of the variables, which is x. Now I can take this greatest common factor of 2x and divide the original expression by it. So I divide both of these by 2x and stick it in front. Then I fill in the parentheses. So 2x divided by 2x is just 1, and x to the third divided by x, as I'm taking away 1x, so it's x squared. Then 4 divided by 2 is 2, and these x's cancel out, so my expression is 1x squared plus 2, and I don't know that I don't really need to include the 1, so it's really just 2x, x squared plus 2 as my final answer. For the next example, I again start by listing my factors, the coefficients. Now the x to the third really has a coefficient of 1. So if I list the common factors of 1, or the factors of 1 is just 1 and 1. Then I'm going to list the factors of 8. So I have 1 and 8 and 2 and 4. And lastly, I list the factors of 10. So I have 1 and 10 and 2 and 5. Now of these factors, they all have a 1. And that's the only thing in common between all three. So the greatest common factor of the numbers is just 1. Now for the variables, I first have x to the third, which means that there's 3 x's. Then I have x squared, which means there's 2 x's, and a single x, which means there's 1x. Now the only thing in common between all three is this single x, so the greatest common factor of the variables is x. Now lastly, when I put this all together, my greatest common factor is I combine the greatest common factor of the variables, or the numbers, which is 1, with the greatest common factor of the variables, which is x, and I can rewrite this as my greatest common factor is just x, because the 1 I don't need to include. Then I can take this x and I'm going to divide the original expression by this x at each term and stick the x in front to factor it out. Now when I do that, the 1's really cancel out. I start with 3 x's, take away 1, so I have x squared. Then the 8 is going to stay the same, so it's plus 8. Start with 2 x's, take away 1, x. And the 10 will stay the same, and these x's cancel out, so it's plus 10. So our final answer is x times x squared plus 8x plus 10. In our last example, I'm again going to start by listing my factor pairs of the coefficients. So for 6, I list the factors of 6, which are 1 and 6 and 2 and 3. Then I can list the factors of 9, which are 1 and 9 and 3 and 3. And lastly, I can list the factors of 27, which are 1 and 27 and 3 and 9. Now for common factors, all these have a factor of 1 and a factor of 3. So the greatest common factor is 3. Then I'm listing it for the variables. So for r to the third, we know that means there's really 3 r's. For r squared, we know that means there's really 2 r's. And just r means there's really just a single r. Now if I'm looking for what's in common, the only thing that's the same for all of them is this r. Give me a greatest common factor of r. Now lastly, when I put this all together, I'm going to write my greatest common factor, and I include the greatest common factor of the numbers, which is 3, and the greatest common factor of the variables, which is r. So now I can take this greatest common factor and divide the original expression by it. So I can divide everything by 3r and put the 3r in front to factor it out. So when I do this, 6 divided by 3 is 2, and r to the third divided by r, I'm taking away 1r, so it's r squared. Then I have 9 divided by 3 is 3. R squared divided by r is taking away 1, so I have r. And then 27 divided by 3 is 9, and these r's cancel. So my final answer is 3r times 2r squared plus 3r plus 9.